Hey everyone, this is Miss Valentine, and you are watching the Water Resources Notes for AP Environmental Science. Water is something that we have talked about a little bit in terms of aquatic ecosystems and how watersheds are set up. So today is really focusing a lot on the human use of water and then also the hazards related to water. All right, so why is water so important? It is a huge portion of our Earth. It covers 71% of the Earth. Most of that is salt water or oceans. And there is no life without water. So any plant or animal requires water to be able to do its cellular functions. And there is no substitute for its uses. It does a whole lot of things that wouldn't be possible without it. And we'll talk about that more specifically. It's important for making the Earth, the topography, what it is today. It helps to moderate our climate, meaning it helps keep things from getting too extreme. And then it also dilutes pollutants. So a lot of the pollution that we have on Earth, it gets spread out or more diluted by the impact of water. So water plays a key role not only in the evolution of life and the continuation of life, but it also shapes the planet that we have. And those components of the Earth create the life that we do have. So water is kind of pivotal, and that's why when we look out into space and we're trying to discover planets that might contain life, we're looking for planets that might contain liquid water. We don't always know for sure that there is liquid water there, but when you hear them identify these planets out in outer space that could be Earth-like, it's because they're in a place related to their star that would allow for liquid water to exist. So liquid water is vitally important for life. And part of the reason why that is because it has some very unique properties. So the hydrogen bonds between molecules are unique. They have a certain amount of flexibility that allows them to flow, and it also impacts their heat capacity, which is the thing that you're writing down now. So heat capacity means it can take in a lot of heat, and it takes a long time to change the temperature. This is why it moderates climate. So a high heat capacity means that the water around the Earth is absorbing a ton of the sunlight, as well as other things like carbon dioxide and other gases. But the fact that water, including ocean water and other types of water, absorb tons of sunlight heat, and that keeps the temperature from getting too extreme in those sunny areas. It also helps to circulate water around the Earth as well, delivering that heat to other parts, and that helps with the climate as well. It also protects organisms for temperature changes. So our temperature is 98.6, or our ideal temperature is 98.6 degrees Fahrenheit. And if we get too hot, if we start to heat up, our body produces water in the form of sweat, and that sweat pulls heat out of our bodies and helps us to stay cool, helps to keep our temperature down below or down at that 98.6 degrees. So it's very important as a coolant for living organisms. It also has surface tension, cohesion, and adhesion, if you remember those terms from biology. All of those help with capillary action of trees and plants. That helps them to bring water up through their roots into their bodies and their stems by those water molecules bonding to each other and bonding to the other surfaces. Because if you think about it, like everything wants to go down with the weight of gravity, but with cohesion and adhesion, water can actually like go upwards, up plants, and provide water to their cells. It has a high heat of vaporization, and that means that it absorbs a lot of the heat when it changes into water vapor. That's one of the reasons why sweat is so important to keep our body temperature down. When water accumulates on the surface of our skin, it takes a lot of heat out of our body in order to turn that into vapor, and that's how sweating actually works. It's also a universal solvent. It can dissolve a ton of things. Anything that's polar is going to dissolve in water, and so that helps break things down. It helps cause chemical reactions to happen more quickly. It ionizes into hydrogen ions and hydroxide ions, so that's pH. Hydrogen ions make things more acidic, H+, and then hydroxide ions, or OH negative, make things more basic or more alkaline. It filters out UV light. So if we didn't have that filtering effect, a lot of organisms in the ocean and that lived in water would be bombarded with UV light. It also, our clouds also help with that as well. The water vapor that's in the atmosphere helps filter out some of the UV light that could damage our cells. And then it also expands when it freezes. It's the only compound on Earth that does that. Everything else in its solid form would sink to the bottom of whatever that liquid form of that material is. But water, because of the way it expands instead of contracting, it floats instead. It's less dense, so it floats on the top of the water. And that actually allows for things that live in the ocean or live in the water to survive because that ice forms an insulating layer, so those things can survive during the winter time. So the unique properties of water are vitally important for life, and that's why we look for it when we're looking for life out in the universe. Here we are at our first pit stop. How does water's high heat capacity moderate Earth's climate? So think about what water does with the solar radiation. Pause the video while you answer the question. So how much water do we have available here on Earth? Most of it is salt water, which is good for some life forms, but not for us humans and other land animals. We need fresh water. And so a small portion, 2.6%, is actually fresh water. And that fresh water is locked up in ice caps and in glaciers as well. It could be polluted. It could be salty, like in marshes. You get some salt water that goes into marshes. And then we also have some in deep groundwater. So all of that 2.6% of fresh water is not available to us. An even smaller portion is available as soil moisture, as usable groundwater closer to the surface, as water vapor in the atmosphere, and as surface water. So a very, very tiny percentage of the water on the Earth is available for us to use for our human uses. So that really kind of, if you look at the percentages there, that really drives home how valuable this is as a resource and how the demand for water is likely to exceed or already is exceeding the supply that we have available to us. So we have to come up with different ways to generate this fresh water that we need. Here is a visual of what we were just talking about, the percentages. So all of the water on Earth, this is what it looks like. Most of it is salt water in the ocean. A very small chunk of it is fresh water. So if we were to blow that up on its own pie chart, you see that a lot of that is locked up in glaciers. And this 1.984% is of the total of all water that is locked up. Groundwater is the other big chunk of that. And then of that, an even tinier slice, this is what we have available to us, so readily accessible fresh water. In lakes, soil moisture, atmospheric water vapor, rivers is very small, and then biota is life, so living things contain water as well. If we were to take and compare all of the water on Earth to 100 liters or 26 gallons of water, you'd have 3 liters of that, or a little less than a gallon, as fresh water out of 26 gallons. That's how much fresh water you would have. And then this stuff that is available for us to use would be a teaspoon or half a teaspoon. So very, very small amount of water on Earth is available for our use. So water is constantly being cycled by the hydrologic cycle, or the water cycle as it's more commonly known, and it's unevenly divided throughout the world. Canada has only 0.5% of the world's population, and they have 20% of its fresh water. It's just the way that it is distributed. China has 21% of the world's population and only 7% of the fresh water. So this is not something that's necessarily human caused. It's just the way that our civilizations have set themselves up around the world. In the future, as our populations grow, we are going to see more shortages. There are some really good documentaries. There's even an episode of Explained on Netflix that talks about the world's water crisis and where in the world these things are starting to happen. These shortages are starting to happen. I believe South Africa was one that I remember. They had a day zero that they were monitoring, like, oh, we're going to run out of fresh water. And luckily they got some rain and they didn't run out of water. But these shortages do continue to be a concern because we need water for a lot of the processes that we as humans use. So it's not just drinking water, but we use it for all sorts of other things. And in the developed world, like the US, we use fresh water in our toilets. So we'll talk about a way that people are trying to modify that to help save some more fresh water. So surface water is any precipitation that does not infiltrate into the ground. So this would be your lakes, rivers, streams, anything on the surface. The other, about two-thirds of that is lost by seasonal floods and can't be used by humans. But a third of it is reliable that we can count on as a stable source of water. So once again, this is water that can be stored in reservoirs, in lakes, rivers, anything on the surface. And truly, anything on the surface that is flowing is considered runoff. It's running towards the ocean. Remember, the force of gravity is causing water to flow from higher elevation to low elevation. Even though it's ever so slight, we can't see that elevation. The power of gravity is causing that water to flow, and that's called runoff. There are watersheds and drainage basins all throughout our land masses, and basically you have small watersheds flowing into larger watersheds and then eventually out to the ocean. So the water, again, is flowing by the force of gravity towards the ocean. So a drainage basin is anywhere where water drains into a stream, lake, reservoir, wetland, or other body of water. So eventually, again, out to the ocean is where the destination, that's where the streams are headed. And here we are at our next pit stop. What type of energy causes surface water like rivers and streams to flow? So I just talked about this. What is it that causes water to head towards the ocean? What is that force, that type of energy? Pause the video while you answer the question. So let's talk about some of the different types of water or fresh water that we have available to us as a resource. Groundwater is just water that infiltrates into the ground, so it flows into the ground and percolates downwards. Percolating is just another word for flowing downward, and it fills up the pores in the soil and the rock. The area above the impermeable rock barrier. So impermeable means water cannot go through. So the area above that rock where the water can't go through, that is filled with water called the zone of saturation. So if you think of something that's saturated, it's completely filled with that material. So think of like a sponge that's saturated, it's completely filled with water. The water table, which is something you might actually hear more often, is the top of the zone of saturation. So it's almost like if there was a storage place under the ground with water, that water table is the very top. So it's usually where you're going for or what you're shooting for to go through the water table if you're digging a well that you want to get fresh water from. Above the water table or above where that top layer of water is the zone of aeration. So think of air, and aeration is the same thing. So there's air and water located in that region. It's a mixture. Usually that's in an area where there's soil or rocks where the water can continue to flow. So the zone of aeration is where you'll find both air and water. The water table and then the zone of saturation below it are saturated with water. So it's almost like an underwater storage location, if you would like to think of it that way. An aquifer is kind of an underwater storage facility for water. It's where there's pores in the either rocks or soil, sand, gravel, bedrock, where the water can flow. So there's pores in the ground where the water can flow and be stored. A recharge area is any area of land where the water is going to flow into an aquifer, into that water storage facility, if you want to think of it that, like a natural underground water storage facility. Nature built it best. They're not just underground pools of flowing water, they're actually more like sponges. So again, storing water. And then a discharge area is anywhere that aquifer is going to discharge that water or send that water. So it could go into a well that we dig. A lake could actually have an aquifer at an equal destination or an equal elevation right next to it. We'll look at a picture in a moment to show that. Streams and geysers, the ocean, those are all areas where the water from the aquifer could go. Now, groundwater, just like any other water, it's moving from an area of high elevation and pressure to an area of low elevation and pressure. So the groundwater is flowing just like the surface water, but it's much, much slower because you have all the rocks and soil and other things in the way. So creating that friction that prevents it from flowing as quickly as surface water. So groundwater is flowing. It's just very, very, very slow and it flows at about 1 meter per year. So this water that is trapped in these aquifers, it's still flowing. It's just incredibly slow. And therefore, if you get pollution or anything in the recharge area in the aquifer, it's going to take a very long time for that to get out. And then if some of that pollution clings to the rocks in the aquifer, it can take even longer for that pollution to filter out. So it's really important that we protect recharge areas so that they're not filling up with pollution that could affect long term. So here's just showing some a visual of the processes we talked about. Infiltration and percolation is where it's moving through the ground into the zone of saturation. Again, the water table is the very top part of the zone of saturation down here, and it's considered groundwater when it's in this zone of saturation. Soil moisture is just kind of existing before it gets down to the water table. You also have processes involved in the water cycle of precipitation, so water falling down. Transpiration is the evaporation of water from plants. And then you also have evaporation from the land itself. And then runoff is any water that's flowing downward by the force of gravity and going off into streams and rivers. So those are all different parts of the water cycle that are important in the flow of fresh water on land. This here is showing you that permeable versus impermeable rock layer. So stuff that is made of clay more than sand or gravel is going to be much less permeable, meaning water cannot get into it. So this is a confined aquifer. So imagine it is surrounded by clay. So it's prevented from getting any infiltration from this part of the diagram here, this part of the land. The water for this recharge area is way up here. So any pollutants down here are not going to impact this confined aquifer. You can put a well deep down into a confined aquifer to get clean, fresh water. Now, this area here is an unconfined aquifer because right above it here are it's most likely sand and gravel, a greater sand and gravel mixture. And so the water can flow through there into this unconfined aquifer, but so can any pollution or excess nutrients or things like that can get into this aquifer. So having a well in there, you may need to monitor the quality of that water a little better because it's more susceptible to pollution in an unconfined aquifer. And then this is showing the runoff on the land. Again, water is flowing from high elevation to low elevation. That's considered runoff. And that goes into streams and lakes, and eventually it'll go out to the ocean. So that is just a good visual of the different parts of an aquifer recharge area. Here we are at our next pit stop. What will happen when soil is saturated or infiltration is slow following a period of heavy rain? So sometimes I see this in my backyard, and you might as well. You can see it at the parks and things when there's been a lot of rain in the area. So what's going to happen if that soil is saturated or full, or the infiltration is slow following a period of heavy rain? Pause the video while you answer the question. So how is water used worldwide? Well, the biggest use is for irrigation, for agriculture. We've got to be able to grow food for us to eat. Industry takes up about 20%, so that would be in a lot of industrial cooling is usually what water is used for. Remember, it's got that high heat capacity, so any machinery or equipment that produces a lot of heat, it cools it down. It's also used in cities and residences, so that's what we think of as our household use. And then in our school, when you're running the sink in the bathroom or flushing the toilet, that's all the rest of it. So a huge amount of it is used for irrigation. And ironically, sometimes the water use in those areas, there's not a huge supply of fresh water. It has to be brought into the area where they do the agriculture, where the plants are actually growing. In Central California, They have amazing soil there. They don't have a lot of water in the areas where they farm, so they bring a lot of it in. And we'll show a picture of the California aqueduct system. So in the United States, we've got lots of fresh water, but we've got it in the wrong places, so where we need it. The eastern states where we live, we have plenty of precipitation, and we also have the Great Lakes right here next door to us. So we have tons of fresh water available to us. My friend in California used to joke like, "Oh, we should like just pipe the water straight out west here," and I'm like, I don't think so. And I think the Great Lakes states all signed a pact not to send the water or sell the water out west, which is kind of interesting. But western states have too little water. So again, they do need some of that water, but we are already drawing a great deal of fresh water out of our Great Lakes as it is. In the east, we use most of our fresh water in terms of like the industrial use. We use it for energy production and cooling during manufacturing processes. So like I mentioned, that high heat capacity lets the water absorb heat from manufacturing and industry. In the west is where we mostly use fresh water for irrigation. So the west, again, they produce a lot of the food that we use in the east. So in some regards, we've got to make sure that we share our source or come up with technology that will make sure that they have enough fresh water so they can supply food for the rest of the country. So it's kind of a trade-off situation. But again, the Great Lakes states have a pact to not sell off our water out west or elsewhere in the world. So there is a lot of water that goes into industry. You don't often think about the things that you commonly use, like even your sweater, your products, everything around you took water to manufacture. So creating one automobile or one car, you need 106,000 gallons of water just to cool off the equipment and the machinery required for that. A kilogram of cotton, so again, your clothes, requires a great deal of water. And so it's important for areas that have manufacturing facilities and industrial facilities to have that fresh water available to be able to make those things. So our most serious problems, like I said, in the east we have plenty of water, and unfortunately we're getting to a point where we're seeing more and more flooding. This is a 2019 map from NOAA, or the National Oceanic and Atmospheric Administration, showing the outlook for flooding. And it's huge along the Mississippi River, especially. And we know that Iowa recently flooded. Where's Iowa? There's Iowa. So Iowa recently had some really bad floods in farming areas and completely wiped out those crops. So excess water seems to be our problem here in the east. But in the west, there is more of a shortage of runoff. So especially in these states here, it's much drier. This is the Central Valley in California, so it's actually good to see that there was a flood outlook there. They need the water there. This coincides with the Sierra Nevada mountain range. So this area, Northern California, tends to get a lot more rain. And then this is a temperate rainforest in Oregon and Washington. There's temperate rainforest, so they tend to get a little bit more rain in those areas. But all other places tend to face more drought than anything else. They've got a high rate of evaporation because of a lot of sunlight, especially there in California and in the Southwest here. So this is just showing the average percentage or average precipitation up here on the top left. So we get 0 to 25 per year in Ohio, or at least in the region that we're in. They get a little bit more down further south. And then this is showing areas with that fresh water is used, and is there a shortage or is there a surplus? We have in our areas where we have in Columbus, we have more than 1 million people here. We have an adequate supply of water. You can see the orange there. There is a shortage, interestingly enough, in this Northeast Ohio. That must be a distribution issue. But you can see in other places, there's a lot greater shortage in the West than there is over here in the East. So what causes water shortages? The climate is the biggest issue. So we've seen a lot of drought, especially out west, as a result of climate change. That's one of the extreme weather consequences we've been seeing. A drought is just a period of 21 days or longer where there's precipitation is 70% below the normal and evaporation is higher than normal. So that causes everything to be dry, including vegetation. the soil, the ground. So you're just without water. And that can result in what's called the official term desiccation, or the drying of soil. And that, of course, affects your growing capabilities. It also impacts runoff. Runoff for mudslides. It can also impact the erosion that can take place in soil. So the drier it is, the easier it is to be blown away by the wind. So desiccation results also from deforestation or overgrazing. And if you have too many people and not enough water, you end up with what's called water stress. So the environment starts to feel the impact of too many people not having enough water. So it's not just stress for humans, it's stress for the environment as well. So you have to make sure when you are adding population in an area that you are also making sure that there is enough fresh water for the people and the environment around it. Here we are at our next pit stop. Describe the major water concerns in the United States. So maybe focus on what is the conditions in the East and what are the conditions or water concerns in the West. Pause the video while you answer the question. So how can we increase our freshwater supplies? We're going to go over a few different types of methods that we use to increase our freshwater supplies: building dams, bringing surface water in from other areas, withdrawing groundwater, converting salt water into fresh water, one of the more expensive and trickier processes, and then just improving the efficiency of water use so that we don't use as much water and therefore get the most out of the fresh water that we do have. So we'll talk about each one of these in detail, and then also talk about some of the newer strategies that are a little bit more alternative, a little bit more in development. So in terms of dams, they are often used to control floods and store water. The Hoover Reservoir in Westerville it was actually built for those purposes, to control flooding in the area and to store water that can later be changed into drinking water and other fresh water for Columbus. We personally in Westerville get our water from the Allen Creek, and then some of that also comes from groundwater. So we'll talk about that in a moment. Dams can also produce hydroelectric power. The Hoover Dam does not in our area, but a lot of dams were set up so that they could have that dual purpose. They supply water for irrigation and other residential and commercial water use. And then they serve as a recreation point. You can go swimming, fishing, boating. Many of us have recreated out at the Hoover Reservoir here in Westerville. Some of the drawbacks, though, is that the water does not bring nutrients downstream. You reduce the water flow below the dam. So the water isn't able to deliver nutrients further downstream. You have silting at the dam, which is just that residue buildup behind the dam. And if the dam breaks, which we've had recent incidences of this happening, the area below the dam will get flooded. And it also destroys natural ecosystems. It floods current ecosystems, and then it dries out ecosystems downstream. So the whole ecosystems have to rebalance themselves. It can also increase water pollution, because instead of letting water flush out towards the ocean, which we don't want the pollution there, but it does get a little bit more diluted when water is flowing. Instead of having that dilution, you're having all these concentrated pollutants building up in an area. And then it can also promote saltwater intrusion, which basically means that salt water is coming in through the ground on the coast. So if you live in an area where there's an ocean right next door, then salt water can find its way into that reservoir. So we'll look at a picture of that in a few slides. Transferring water from one area that has a lot of precipitation to one that does not is pretty common out west. Aqueducts are these cement rivers that California uses in the California Water Project to move rain from northern to southern California, where most of their agriculture and most of their population is located. And then Canada also has its own transfer project where they're bringing water from areas that have a lot to areas that don't. In this slide here, you see the California aqueduct system. The blue here are these cement rivers that I mentioned. This is the area where most of our food for the United States is grown in this Central Valley because the soil is very good, but it's pretty much like a desert. I remember when I lived there, I lived in Fresno, if there was a cloud in the sky during the summertime, it was like, whoa, like there's a cloud. It's so sunny, it's so dry, but you have all these aqueducts flowing through it to deliver fresh water. And they're coming from the northern part of California, which gets the most rain, and also pulling from the Colorado River. So Coloradans are actually very limited in the amount of water that they can get from their local streams. You can actually be fined for taking water out of freshwater streams because that water has already been sold to Southern California. So it's interesting out west, the way that they have to deal with fresh water since there is such a shortage. Groundwater is another option. It's one that we use in Westerville. I believe when I've toured the water treatment plant before, they said like 10% of the water that the city used that year, I think it was last year we went there, 10% was groundwater because at sometimes Allen Creek is too low to get enough water for our city to use, so they draw it out of the well that they have by the water treatment plant. This can be done year round. So anytime you have a shortage of water, you can pull from the well as long as there's enough water there. The water isn't going to be lost by evaporation because it's trapped in the ground. It's not exposed to the air and the sunlight. And it's less expensive to drill a well than it is to develop an aqueduct system where you're creating cement rivers. In groundwater, though, when you draw water out of the ground, it lowers the water table. It can cause land subsidence, which means the land is literally sinking because the water is not there holding up the rocks and soil. And I'll show you a picture in the next slide of that. It also can cause saltwater intrusion when you pull water out. It's almost like it's sucking the salt water from the ocean into the groundwater. And again, I'll show you a picture of that in a few slides. It also moves contaminated chemicals towards the wells because you're sucking water. So if there's an area that's contaminated, it's pulling that water towards the well. And then that also reduces stream flow because remember, groundwater is moving ever so slowly, just like surface water towards the ocean. And so it's moving into streams. If you're drawing that water out, you reduce that pressure that would normally push it out into the stream. So it reduces stream flow surrounding the area. On the left here is a picture of the Ogallala Aquifer, which is used in the Central Plains states to water crops. And you can see there's a high overdraft of water. So basically this just means that the amount of water that is being recharged into the ground is a lot less than the amount that's being drawn out of the Ogallala Aquifer. And so you can see in these areas, there's extreme shortages. I think it's more than 45 meters below what is being replenished by precipitation. So drawing groundwater can create shortages, but it also can do, this is called land subsidence. So the land is subsiding, it's sinking. This is in the San Joaquin Valley in California, that Central Valley I showed you. In 1925, the ground was literally up at this level of sea level, and it has sunk. This is over a 50-year period, and it's 50 years since then, so it's probably sunk even more. And since the entire land is sinking, it's ever so slow, you don't notice on the surface, but the water table underneath is lowering, and that's causing the land to subside. This image is just showing you that saltwater intrusion. So if you live by the ocean and you have wells, you want to build them far enough inland that the water you're sucking is not filled with salt water. So you can see if you're drawing water out of the ground, you're pulling groundwater to flow towards an area of lower pressure. So you're pushing the salt toward further inland. So you have to be very careful of that when you live near the ocean and you're using wells. Desalinization is just removing salt. And it's removing salt usually from ocean water or brackish groundwater. Brackish would be like filled with minerals and salts. Distillation is a process that is used, and so is reverse osmosis. Both of those are energy intensive. Think about if you were like on a desert island and you wanted to remove salt from the water so you could drink it. You'd have to boil it, and that takes a lot of heat, a lot of energy. So it's the same with these official processes of desalinization. It takes a lot of energy to make them. And it also produces a lot of wastewater called brine, and we actually do use that brine to salt our roads in the wintertime. So it can be used in areas that are snowy, but if you think about where they're doing the desalinization, it's out west where they don't have as much snow versus out east where we have the snow where we could use that brine. Some of the more modern or highly alternative forms of freshwater production would be cloud seeding and towing icebergs. Silver iodide is something that will cause the clouds, the water vapor, to turn into liquid, to condense into liquid much faster than it would normally, and that makes it rain. So they call it cloud seeding. So you're basically spraying a chemical on the cloud and it causes it to rain. But that puts chemicals in the soil and in the water. And then you also have legal disputes over who owns those clouds, because clouds are moving across the sky. It seems kind of crazy to us here in the East, but out West, that is an issue. Another radical kind of idea is towing icebergs into land. And there's actually companies that make beverages that are like iceberg water. But using that fresh water from icebergs and directly bringing it to places that need it, that's also another type of technology that's being explored. But again, as most new technologies are, it is very expensive, and then it may not be sustainable in the long term. We, at some point, will run out of icebergs. All right, so here we are at our next pit stop. Which of those methods that we've discussed for increasing freshwater supply is likely the most sustainable in your own opinion? And you're welcome to mention more than just one. Pause the video while you answer the question. All right, so let's talk a little bit more about how we can use water more efficiently. And this is one of the major solutions that governments and policymakers are pushing forward because we do waste a lot of water. It's estimated that 60 to 70% of the fresh water that we use is wasted through evaporation, through leaks in pipes, and other things that might cause water to be wasted. So I know that my bathtub faucet right now is literally dripping. And so that wasted water could have been used for agriculture or for other things. So getting these things taken care of is super important as well as increasing the supply. So why do we waste so much water? The government subsidizes the true cost of water. And we've talked about true cost before. If you have cheap water, you're less likely to get the bathtub fixed or use less water to water your lawn. If it's very expensive, then you end up conserving a little bit more. Fragmented watershed management is where you have supplies divided among local governments. And so you don't have a cohesive system for how water is managed. And that can result in inefficiencies as well. So these are a few different reasons why we waste so much water. And if we were able to reduce waste in irrigation and in agriculture, we would actually save a ton of water, since that is the biggest area of water use throughout the world. Only about 40% of water actually reaches crops. A lot of it evaporates in the process, especially in dry areas where it's brought in from surface water or through aqueducts. You can use a center pivot farming technique. So sometimes if you've ever flown in an airplane and you see the circle crops around the ground, that's a center pivot sprinkler system. So you'll see that often out west where water is more scarce. You can also use lower energy precision application sprinklers. So these ones are very precise in the location that they're putting the water. You can use time controlled valves so that they're watering at times of day that won't result in a lot of evaporation. Use soil moisture detectors so you're not watering plants or watering soil that doesn't need it. Oftentimes, I used to walk on campus in Bowling Green, and this was just watering the grass, but it would be raining outside and the sprinklers would be on. So like if you used a soil moisture detector to determine like, no, we don't need water right now, then you wouldn't be wasting that fresh water watering a lawn while it's raining. I'm sure you guys have seen that before too. Use drip irrigation systems. So this would actually be kind of like a hose with holes in it, and it just puts water directly at the roots of the plants. So you see this a lot when in orchards where they're growing trees and things. But this would prevent a lot of the water from evaporating. The water that normally is just sprayed overhead over top of the plants, a lot of that evaporates and doesn't get to the roots of the plant. So drip irrigation is one way to mitigate that. So this is showing different types of irrigation. This drip irrigation is what I mentioned before, is like a hose with little holes in it, and it delivers water directly to the source. A low pressure center pivot has a higher efficiency. So a lot of times if you're flying over the plain states or out west where it's drier, you'll see this. And then this one, I didn't mention the gravity flow. It does have a greater a percentage of water that gets into the ground than our traditional overtop irrigation methods as well. In homes and businesses, you can do a new design of your lawn called xeriscaping is the name of it. So I have some pictures of some xeriscaping. Essentially, you don't have to mow your lawn, so it's nice in that respect too. My cousin lives in San Diego, and he xeriscaped his lawn. So it's mostly stones and rocks, and then you have other plants that are that are drought resistant plants. You can use drip irrigation to water your lawn instead of the overhead irrigation that causes evaporation, and then use water meters to monitor water use. We actually do have monitors in our area. And then you can also raise the price of water to cause people to try to reduce their water use, because just telling people that they shouldn't waste water doesn't always work. Only if it hurts their pocket are they going to change their behavior. So xeriscaping is really cool, though. If you look it up online, there's some really cool designs and things you can do in your yard if you live in a drought-prone area. We get quite a bit of precipitation here, so we don't have that much problem with dry lawns. In homes and businesses, you can also use what's called gray water. And that is what the picture is I'm showing here. Here's some other home things that you can do. And the gray water system is where you take wastewater from certain processes in your home, like washing your hands or showering or laundry, and you use that gray water. You pipe it into a storage system here, and then you use the gray water for watering your plants or flushing the toilet. So you're not piping in drinking water in your toilet. In fact, like if you were trapped in your bathroom and you needed to drink water and your sink wasn't working for whatever reason, you could drink the water out of the tank of the toilet. You wouldn't want to drink out of the bowl, obviously, but you could drink the water out of the tank of your toilet, where the water is stored before it goes into the bowl, because it's fresh water. So gray water systems are trying to reuse the water in your home that isn't damaging to water plants and to flush the toilet, things that it doesn't really matter if you have fresh water for those. All right, here we are at another pit stop. What water saving solutions would be the most sustainable or would have the biggest impact in your opinion, and why? So kind of read through those items and write down what you think would be the most effective in terms of saving water. Pause the video while you answer the question. So our next topic is flooding and some of the hazards caused by too much water. Flooding generally is caused by melting snow or heavy rainfall, which we see a lot more heavy rainfall lately. Streams often overflow into natural floodplains, and that provides natural flood and erosion control. And it helps us maintain our water quality to have an area where the water can go that doesn't have any like pollution or human like fertilizers or other chemicals. That helps to have that floodplain. It also provides an area to recharge groundwater. So floodplains are a natural part of the landscape, the lay of the land, and they are important for a number of reasons when it comes to too much water, to flooding. So here's a picture of a floodplain. You can see here it does have fertile soil, so you can plant during certain times of years after the flooding season. It can provide water for irrigation around the floodplain, and it flattens out the area for farming. Again, you want to do it after the flooding season, usually in the springtime is when it floods. And then it also can help with transportation and recreation, just having that extra water supply available to flow into those rivers and streams. So floodplains, you'll see these often close to rivers. Alum Creek has its own floodplain. I think I have a picture of the flood zone in Westerville. I'll show you guys in a little bit. But there is a problem if you try to build on floodplains, and that was the case in Hurricane Harvey in 2017. Texas had been in a drought for many, many years, and they started building on floodplains. And so when the water did come back, you end up seeing this neighborhood like this where it's flooded. It's in a floodplain. So some of the ways we can reduce the severity of floods is to leave vegetation on hillsides, don't build on floodplains like they did here in Texas, and don't drain the wetlands. And then the question is, going forward, do we rebuild this neighborhood here? Insurance and FEMA usually do rebuild these houses on floodplains, which just at this point just seems absolutely crazy. But policyholders or policymakers need to rethink how we are recovering from disasters like this. We know that it's going to flood again at some point, so why would we rebuild it? So that's something that currently is a movement in policy and in government, is to try and get these people to relocate rather than keep building on floodplains. So that's where public policy is very important. Channelization is when you actually build a place for the water to go. So you can straighten streams out to allow more runoff to get into it. It does reduce flooding, but it also increases bank erosion and other downstream flooding issues. So you can try and manipulate nature, make the river the way you want it to be, take the water away from where you want it. There's usually a consequence for doing that, though. So you can't take a big action like this and not expect things to be affected further down. And just looking at the project in the picture here, it's really expensive to do this. So determining where you're going to live or build structures is probably more important and a lot cheaper than going back after the fact and building these channels. Unfortunately, with climate change, you're seeing a lot of unpredicted weather patterns that we didn't have before. So we built our businesses in our towns and areas that are now prone to flooding, that maybe if we had known what was coming, we wouldn't have built them there. And channelization also can ruin habitats. As you can see here, it looks like they cut it through the woods here. So you're destroying habitats and causing habitat fragmentation. Artificial levees. This is kind of a cool picture down here of a farmhouse. I think this is in the Central Plains, maybe Iowa or something, where they built this levee around their house because the Mississippi River was flooding so frequently. So when it floods, they are surrounded by an artificial levee. So it's basically just taking the land and building it up, making a hill. And so it does help contain water flood problems when they occur. So, and you can see here, this looks like where they would enter when it's not flooding. There's like a little gate there. I just think that's the silliest picture, but people have to do it. And then flood controlled dams like Hoover Dam, they store water in the reservoir and then release it gradually. And it gets really concerning though when you see those dams full and the water just flowing rapidly. That's generally when dams become compromised. So it's one of the reasons we're seeing maintenance on Hoover Dam right now. So floodplain management is the best approach to managing water. So actually looking at the entire lay of the land and implementing strategies to help control it. Looking at the vegetation in an area, coming up with an official, plan. Rain gardens have been a huge part of Central Ohio planning commissions. Columbus put some in neighborhoods where there was a lot of stormwater runoff. My parent-in-laws, they have a rain garden that was put in by the city of Columbus outside their house. And this is a flood map that you can actually look up for Westerville, and it's showing here along Alum Creek. You can see that's where most of our floodplains and our bigger, the bigger threat for flooding is along those areas on Alum Creek. This up here this is Hoover Reservoir, I believe. So you can even look up your own flood risk in your area, or if you're going to buy a house, you can look up the flood risk before you go buy that house. All right, guys, so here we are at our summary. I'm limiting it to 7 sentences this time. So write a 7-sentence summary about the issues related to freshwater supply and the conservation of fresh water.